Okay, so here's a good free response question. It's typical. You see a graph of F, and it looks like you're going to have to calculate areas at some point. And they're asking a lot about this function G, which is defined as F. So I'm going to do this video probably in parts because I started it and I screwed something stupid up on B and I had to redo the whole thing. So not that you care, but that's why I'm going to split this up into parts so I don't have to keep restarting because I know I'll screw it up. So anyhow, we're going to start with that. Given this graph of F and G, we're supposed to find G of -3, G prime of X, and G prime of -3. So let's start with G of -3. G of -3 is just plug it in. So G of -3, given that G of X is 2X plus the integral from 0 to X of f of t dt, G of -3 would be 2 times the -3 plus the integral from 0 to -3 of f of t dt. So you're just plugging -3 in for x. 2 times -3 is -6. The integral from 0 to -3 of f of t is you have to take the graph of f and integrate it. In other words, calculate this area from 0 to -3. And remember, this area would be positive because it's above the x-axis normally, but we're going from right to left, so it's going to calculate as negative. This is a semicircle, or I'm sorry, it's a quarter circle because it says it's a quarter circle. I just don't assume it. And the area of a quarter circle would be a quarter of a whole circle, so a quarter of pi r squared. The radius of this circle is 3. So this would be 1/4 pi times 3 squared, or just 9/4. But remember, it's going to be negative. So there's, I forgot my pi. There's G of -3. So that wasn't too bad. The next question is, what's G prime of X? So here we go. I'm going to get rid of all this stuff because I already have, oh no, I'm not. This isn't working out how I wanted to, but G of X is 2X plus the integral from 0 to X of f of t. So G prime of X is just the derivative of that. So G prime of X would be the derivative of 2X is 2 with respect to X. And then we have to take the derivative of this definite integral that has a variable upper limit with a constant lower limit. We're taking the derivative. So this sounds very much like the second fundamental theorem of calculus, or at least that's what we call it. And to do this, all you do is take this upper limit and plug it in for the dummy variable, sometimes u, sometimes t, and then multiply by the derivative of what you just plugged in. The derivative of x is 1, so you're done. So that's G prime of X. And then the third question is, what's G prime of -3? Well, if you have G prime of X right, that should be easy. You just plug in -3 for X. So now we have to do f of -3. This is the graph of f. So you just look for -3, which is right here, and its value is 0. So it's plus 0, you're done. So that wasn't too bad. That was part A. Stay tuned for part B.